Hello everyone, welcome to today's video on chromatography. Now chromatography is an analytical method that we use in order to separate substances that we find in a mixture. Now we can use this method not only to separate the substances in a mixture but also to try and identify substances that we've separated. Now what you can see at the moment in front of you is a piece of paper which we call a chromatogram. Now at the bottom of there I have put a line in pencil, and I'll come back to why I've done that in a second, but on that line I've put a dot of red substance, a dot of green substance, and a dot of an unknown substance. Now the whole idea of this method, as I've just said, is you're trying to separate the substances that we find in a mixture. So in our unknown substance here, which is a mixture of different inks, what we should see at the end is that we could separate out the substances that make up that unknown substance. Now the reason I've put the other two there, they're not mixtures, but if, for example, the unknown mixture contained some red, wherever that red dot gets to on this side of the chromatogram, at the corresponding level on this side, I should see this roughly the same shaped dot, which would indicate that the unknown shows the same, or contains, the same substance that we find in this solution here. Okay, now I said the line that I put along the bottom, I've done it in pencil. Now the reason I've done that is because if I'd done it in ink, it would mix with these inks here, okay, and it would obviously run with those inks. Now the idea here is to separate any substances that make up the solutions. So what I'm going to need for that is a solvent, and in this case the solvent I'm going to use is distilled water. Now really important here, if I put it this way, my chromatogram is going to sit, or rest should I say, on my beaker, just like that if I turn it this way. Okay, now what we want is our solvent to touch the very bottom of our chromatogram paper. The solvent then moves up through the paper just like it would through filter paper, and as it moves up it will separate the substances that make up those inks. Now it's really important that I don't put more solvent into the beaker, or too much solvent so it goes above the line where I've put the dots, because if I did that the solvent would leak out, the ink would leak out into the solvent. So if I make a start now, and it's going to be just under a centimetre. Okay, now if I leave that will leave it for a few minutes, and I just allow enough time for the solvent to absorb into the paper, and I'll come back to it shortly. Okay, so what we can see now is the chromatogram after about 5 minutes or so left in the solvent. Now what we can see is that the inks started at this position here, and they have started to move up the chromatogram. Okay, now we often carry this out to see if a certain substance is present in a mixture. So in order to do that, we have a pure sample of that substance, or a reference, alongside the unknown mixture, which is what we've done here. And then what we can do is calculate something called the RF value for the reference and one of the spots in the mixture. So if we calculate this RF value for the reference and then the mixture, and those both match, what we can say is that the substance is probably present in the unknown substance as well as obviously in the reference. Okay, now in order to calculate the RF value, we need to measure two things. Okay, now the RF value, if I just take that away, The RF value is the distance travelled by the substance, and that's divided by the distance travelled by the solvent. Okay, so what we need to do is leave this a little bit longer, okay, because we will get to a situation where the solvent continues to travel up the chromatogram, but the substance stops travelling. Okay, now at that point, what we can do is measure the distance that the solvent has travelled. So measure all the way up to where it stopped, and then measure the distance from the line to the spot where the substance has travelled to, and then do that distance divided by the distance travelled by the solvent, and that will give you an RF value. Now if we go back to the PowerPoint, that will give us more information on RF values and how we calculate them.